I am a software engineer with TD Securities, and I'm so excited to be speaking with you guys today. I wish an initiative like Hackergal was around when I was your age, and I feel so old saying a phrase when I was your age, but it's true. I was well into university before I wrote my first program or took my first computing class. When I was going through elementary school, high school, I had basically no exposure to computer science. My impression is that I wouldn't be technical enough to ever code, and before even trying it, I just assumed my mind wouldn't work that way. Um, but it was later in university that I started to take coding and computer science classes just out of pure interest, and I loved it. It was an approach to problem solving that just clicked with me. I had graduated from Queen's with degrees in economics and computing and had joined TD for the Rotational Developer Early Talent Program. And the people that I had met in technology have been the most creative thinkers and fantastic personalities I've had the pleasure of meeting. I hope my career serves as an example that it's never too late to take up a discipline, and it certainly doesn't hurt to start exploring early like you guys. The fundamental thing I love about technology, math, engineering is that it's a form of problem solving. When you take the time to engage and hone your technological skill set, you're readying your problem solving toolkit. What you learn today will be what you can apply tomorrow. And you don't just use technology to solve technology problems, you can apply technology for solutions just about related to anything: healthcare, business, education, and especially to our theme of sustainability. Coding together for our planet means that we can use technology to create environmental simulations. We can use technology to monitor and manage resourcing, power usage. We can use it as a means of connecting people with haves and have-nots to minimize consumer waste. The intersectionality between technology and sustainability offers countless opportunities for solutions to be proactive for our planet. As well, one of the beautiful things about technology is that it keeps changing. The tech tools that we'll be using a couple years down the line probably haven't been put on the market. New programming languages are being written, new capabilities are being created, and they'll probably be done so by people like you and who you'll be able to relate to. So, on that note, I wish you guys very good luck with your project and hacks, and I'm going to pass it on to the Hackergal team for the coding session.
Thank you so much, Mikhaila, for sharing your inspirational message with our Hackergal community. My name is Francesca, and I am the Program Development and Delivery Assistant here at Hackergal. Together, we will problem solve as a team to build a project that features animations using both movement, directional, and shape-based commands. You can code along at your own pace by pausing the video whenever necessary. Without further ado, let's get right into the learning objectives for today's webinar. The first step to creating animated movements with turtles includes deciding what type of animation you'd like to incorporate into your project. Let's explore a couple different types of character movement. The first type involves animating the turtle around the workspace in different directions. Keep in mind that the dimensions of the Lynx workspace are 450 pixels in height by 800 pixels in width, converging at 0 pixels in the middle. A great way to give the user control over character animation in any project is to code movement keys. Add 4 buttons by heading to the plus button in the Procedures pane and selecting Button. You can rename these buttons North, East, South, and West by right-clicking on their dialog boxes and renaming them, or by heading to the project tree and selecting the page, then the button, then Edit, equally bringing up their dialog boxes. In the Command Center, let's begin setting the directions for each key. Call upon the turtle, then use the command set heading and the input of 0 to ensure that the direction of the turtle will face north when selected. We can create new procedures in the Procedures pane called to North, East, South, and West, respectively, and bring over the first command, set heading, and the number of degrees depending on the direction. Ensure to link these procedures as on-click events to their corresponding buttons by opening up their dialog boxes and selecting the procedure name. Next, we establish the character animation that will take place when the user selects each movement key. Let's imagine that when the user selects the north and south keys, the turtle advances forward. In the command center, type forward, then an input of about 5 pixels. Now we add the command wait, followed by an input of about 5 before the next advancement. On Lynx, time measurements occur in tenths of seconds, meaning that a wait command of 5 is equal to around half a second. It is suggested to use wait commands no lower than 5 to ensure user accessibility when interacting with the project. The last step involves adding a forever command before the pre-typed code, then enclosing that code in square brackets to ensure that the forever command applies to the code. Add this line of code to the north and south movement keys and test it out. Does your turtle's heading change, allowing it to progress forward? When the user selects the east button, the turtle advances while also rotating. Heading back to the command center, we'll keep forever in the open square bracket. But let's change our forward input of 5 to 20 and maintain the wait command of 5. Next, we'll use the repeat command and an input of 4, followed by an open square bracket with the forward command and an amount of 20, followed by the command write and an input of 90. Since 90 multiplied by 4 is equal to 360, a perfect circle. We can add a wait command with an input of 1 so that the animation effect displays to users. Finally, close the square bracket, then add forward with an input of 60 and a wait command with an input of 5 to ensure that the turtle progresses across the screen, followed by a final closing square bracket. The last step involves adding this line of code to your east and west keys. Imagine adding a pen down command to this animation to allow the movement to trace on the workspace. Animated movement is particularly useful in coded digital games. Let's begin by establishing the starting positions of turtles on the workspace. We recommend establishing a set starting position for your turtles as a way to ensure consistency within your program. Let's set the X and Y coordinates to specific places on the workspace by foregoing the random command and simply using set X or set Y and an input, such as set X -50, set Y 0. We can also create some boundaries which have certain consequences on turtle movement. Let's add one turtle, renaming it and placing it somewhere within our project. Let's try the top hand pane for this example. Right-click on T1 to open up its dialog box and head to the On-Touch Event drop-down menu, selecting New. This creates a new on-touch procedure in the Procedures pane. An on-touch event means that the turtle will run certain instructions only if it interacts with another turtle. In this case, let's create the conditions that if T1 touches the new turtle, it moves back. We type in this new procedure if touch turtle equals asteroid open square bracket back 100 closing square bracket. Test out this code to see if the turtle moves back when interacting with this new obstacle. While women represent a large percentage of the video game buyers market, did you know that they only account for about 22% of the video game development industry, also known as video game developers? A case study conducted by Feminist Frequency, a nonprofit organization advocating for equity in the gaming space, found that women and girls' main characters appear in less than 10% of video games. Advocates in the space emphasize that in order for diversity, equity, and inclusion within the video game industry to take place, women and gender diverse folks must be behind the game's development and storylines. Women are essential to designing the games in which all video game users play in order to reflect their perspectives and experiences. If game development is to be more equitable, then video game developers and video game characters and storylines must represent all the individuals who play them. Another very important way in which to animate objects is through shape commands, also known as changing the clip art of the turtle. Let's imagine that as the turtle progresses across the workspace, we want for its shape to cycle through different versions. Animators and video game developers use multiple copies or iterations of clip art and set the shape to those in order to create this effect. Copying over the movement line of code from our north and south movement keys into the command center, prior to forward 25, we can type set shape 1 and set the turtle's shape to the first clip art image. Next, let's modify the wait command to 15 in order to avoid rapid movement. Next, type set shape 2 and set the turtle shape to the second clip art image. Then let's add another wait command so that we can see the turtle shape change. Make sure to add the updated line of code back into these procedures in the procedures pane. As for the east and west movement keys, we can equally copy over the movement line of code into the command center. Then add the two set shape 1 lines of code before the initial forward command and modify the wait command to an input of 15. The second set shape 2 can go before the turtle rotates. Experimenting with the north and south keys, we can also define a range and use the random command to toggle between a set of clip art. If we have two clip art images, we can type set shape 1 plus random 2 to ensure that the turtle cycles through the first turtle plus the second one in the clip art pane. Copy over this new line of code into your north and south movement key procedures and watch the desired effect take place. In order to render your project accessible and informative for all users, it is highly important to add text descriptions to all project imagery and animations. Let's begin with the movement keys. We can add a text box that prints text and clears it to make room for the next message. Head to the left of the procedures pane and select the plus button. Then find the text option. Rename your text box to something that makes sense to you, like text box. Next, head to the north movement key and on the first line of the code, type text box, comma, clear text, print, open square bracket, Earth moves north in a straight line, closing square bracket. Copy this line of code into the north movement key and modify the direction in the copy. For the east and west keys, modify the copy to say something descriptive like Earth moves east or west, then rotates once in a full circle, then continues progressing across the horizontal plane. You can also modify the messages to include the starting position of the turtles, as well as add an announcement to the on-touch procedure using the command announce, open square bracket, you interacted with an asteroid and moved backwards, closing square bracket. The clear text command ensures that once the user presses a new key, the message is erased from the text box, and then the new one is printed. Finally, modify the message to include the different shapes that the turtle takes as it moves throughout the project. Thank you so much for coding along with us today. We absolutely cannot wait to see how you incorporate accessible animation into your hackathon coding projects. Make sure to check out all of our other video tutorials on the Video Hub, on the Explore section on the Hackergal Hub to continue embellishing your coding projects. Until next time, happy coding!